Welcome to Setting Course, an ABS podcast where we're charting the future of the marine and offshore industries. I'm your host, Brad Cox, and today we're diving into a couple of cutting-edge technologies that I find really interesting. We've talked about additive manufacturing on the show before, highlighting some of the big benefits and the role of digital warehousing. Today, we're going to be exploring how data analysis and machine learning could help build trust in those 3D printed components and what that could mean for AM's role in the maritime industry. To provide insight from the manufacturer's perspective, we have Conrad Kao, Director of Additive Manufacturing at Howco Group. Howco manufactures and distributes alloys and components for use in some of the world's most challenging applications, including oil, gas, chemical processing, and the commercial space industry. Thanks for joining us in the podcast studio, Conrad.
Thanks for having me.
It's also great to welcome back Michael Kei, ABS Vice President of Technology for the Americas. Thanks for joining us, Michael.
Thanks, Brad. Always.
So to get us started, I do want to look at the bigger picture. So Conrad, why is additive manufacturing getting so much attention these days, and what can it mean for industries that really embrace it?
Yeah, absolutely. So I got my start in additive manufacturing about 10 years ago, working for one of the service companies, and we were trying to get engineers to adopt this new metal printing technology. And they approached it from strictly a supply chain perspective of just trying to get existing components and seeing if it could print them. Turns out we can print them, but it's not just cost effective, right? So what we're finding now is there's so much more experience on the design engineering side of things. Engineers actually know how to design for additive and take advantage of the complex geometries that are made available to them. That paired with better understanding of post-processing and material properties, those two aspects combined, we're seeing a lot more adoption by the oil and gas companies.
So, what's been the experience with those parts so far? Like, what's been the performance? Is it on par with, traditional manufacturing?
Yeah, absolutely. We have parts in the field right now. Almost every single major player in the service industry has downhole components. In most cases, you can either meet or exceed traditionally wrought material properties with specific heat treats, HIP cycles, especially of stainless steel alloys and nickel alloys.
Michael, what can AM mean for marine and offshore in particular? And, what's that potential?
To reinforce what Conrad has actually mentioned, AM allows design freedom. So basically, you can design parts that are traditionally not manufacturable through the traditional methods. In addition, you can look at new materials. There are a lot of exotic materials that have been studied right now. They are not part of the traditional supply chain at the moment. So you can just imagine if you're able to print something that is of a different shape, different component, but serves a better function in terms of strength and endurance. That is what AM can actually bring.
So, focusing in on our core topic, Michael, I expect you'll have a lot of insight to this. Trusting your equipment when you're out in the ocean is critical. How are components validated today, and how are technologies like machine learning changing that approach?
Additive manufacturing takes what used to be a series of manufacturing tasks and rolls them into a single and digital build. That's powerful. It also changes how we help make sure that the parts are safe and reliable. So in traditional manufacturing, quality checks happens at every stage of the process. So it's like guardrails along the road. Whereas with AM, many of those checkpoints disappears. So we need smarter, data-driven ways to verify the outcomes and keep the same level of trust and certification. So certification for additive manufacturing isn't just a tick in the box. It's about meeting industry standards, proving safety, controlling the process, and building confidence for ship owners and OEMs. Traditional manufacturing leans on decades of data and mature processes like casting, forging, and machining. So qualification is lighter, variability is lower, and testing is minimal. Whereas AM is newer and more complex, so qualification is more rigorous at the moment with heavier testing and detailed process records. Today, that means extensive physical testing, material certification, process qualification to show repeatability. It's a lot more rigorous than traditional manufacturing, which relies on decades of proven methods. But here's the exciting part for AM, is that it is digital in nature. So it's designed to production, integration, rich process data, and full traceability. So it opens the door to faster, smarter qualification. So the industry is moving towards model-based approaches, physics simulation to predict performance, machine learning to reduce testing, and in-situ monitoring with digital twins to validate builds in real time. So it's basically an end-to-end digital records of the full manufacturing cycle.
So you mentioned trust. I know that's going to be the buzzword today because, I think a lot of this is trust in the data, trust in data collection, trust in data analysis, and even trust in additive manufacturing. Conrad, can you provide some more insight into how Howco approaches validation and what's your perspective on using machine learning to support this?
Yeah, so Howco, we operate as a contract manufacturer for additive manufacturing. And so our approach it's dictated by our customers, which is still based on traditional methods, right? So we still do mechanical testing, NDE where it's required. But I guess to emphasize what Michael is saying, there's a tremendous amount of data being captured currently with additive processes. And it only makes sense to utilize that data and eventually build profiles or models to pre-qualify, if you will, and use components. The cost and lead time involved with traditional validation can be, thousands to tens of thousands of dollars per part, often adding several weeks to months of lead time as well. If we approach this from a digital perspective, the opportunities are to save a lot of money for everybody involved.
So Conrad, can you go into a little more detail as to what traditional testing involves?
Sure, absolutely. I should take a step back even further and say for the oil and gas space, we have standards like the API 20S guideline that basically separates components into different criticality groups. Depending on the criticality, maybe we would do some density testing, mechanical properties such as yield strength and tensile strength, all the way to the most critical where you do non-destructive evaluation as far as CT scan and other similar types of testing. Currently, for the vast majority of parts, we're doing yield strength, tensile strength, Sharpie, hardness testing. And then in certain instances, if it's required by customer, we'll do the final CT scan.
And so in the scope of what we're talking about here is you're capturing that data up front, and that tells you that it meets standards before you have to do any of that stuff.
Sort of. So with the process, you're utilizing the in situ data to build a profile for what a good part would look like. At least this is how I understand the potential. So you would run enough tests using a known component, build it, do the physical testing, build that profile, and then based on that, you can say, this is the profile of what we've input, and assuming there's no anomalies, we're going to get a good quality part at the end.
So it's like the training people may have heard about when referring to things like AI and ML.
Absolutely.
So I'd like to talk a little bit more about that machine learning aspect. We had a recent episode about robotics, and we discussed how the growing availability of processing power and the AI ML boom is really supporting some big advances. So Michael, how are these advances overlapping the additive manufacturing world?
One of the biggest differences between additive manufacturing and traditional methods is that AM is fundamentally digital. That means that we are not just printing parts, it's about enabling digital inputs, outputs, real-time data capture, feedback loops, and advanced controls, and that traditional manufacturing simply doesn't offer. Where it gets exciting is with the advancement of sensors and data collection technology that has improved dramatically, giving us incredible visibility into the build process. So you combine that with machine learning, the impact is huge. AI-driven insights are helping optimize processes, detect defects in real time, and even predict part performance before printing. So this is critical for industry like energy and maritime, where certification and reliability is non-negotiable. The way ABS sees it is that machine learning can actually contribute to additive manufacturing in maybe 4 ways. One, process monitoring and control. So it detects defects on the fly, actually while you're producing the parts. Predicting quality assurance. So it forecasts strengths without the need for extensive physical testing. Validation and certification using digital twins and automated inspection to speed up approval, and of course, design optimization, where the machine learning and potentially even generative design that can give you more optimized designs.
And Conrad, how do you see all this data processing capability impacting additive manufacturing? I know we've talked a little specifically about the validation aspect, but what about the big picture?
I think the big picture is that it's going to help increase adoption. We're already seeing an increase in adoption across multiple industries for additive just due to the education of designing for the manufacturing method. One of the restrictions now is trusting that we're going to have a quality part. The more advances we can make in reducing the lead time and cost of validating components, the more likely engineers are going to use this process, right? So I see it as a key way to mass adoption for additive manufacturing.
For the sake of our listeners and just kind of setting some, I guess, guardrails in a sense, where, a lot of people will hear AI, machine learning, LLM, all this stuff, and just think it's all just one thing. And it's really not. Can one of you provide some, to use the word again, guardrails as to what we're talking about here when we are talking about using this data-driven approach for additive manufacturing?
I don't claim to be an expert on either AI nor ML, but my simple understanding of it is machine learning is much more large data set focused for a specific use case. And artificial intelligence is also a large data set focus, but using all of that data to predict future outcomes. Whereas the ML approach is taking that data set and finding the discrepancies or anomalies within that data set. Correct me if I'm wrong, Michael.
Yeah, I think machine learning is a subset of artificial intelligence. What machine learning does is to get a large set of data and to figure out what the norm is. So the predictive part comes from what has happened in the past. Whereas from a larger scale, AI can actually be predictive. It can generate or create something out of, I would say, nothing. From a certification point of view, AI would be slightly more challenging to adopt at the moment, where machine learning is basically collecting what historically we have and the experience we have, and then have the machine go through whatever that we have picked up during production and make a judgment based on that. So that would be a lot easier in terms of building confidence rather than going right into AI where it starts to make estimation or prediction on its own without having actually the guardrails that you mentioned.
For me, it's taking all this existing data. We're literally talking about gigabytes and gigabytes of data per build, per part of information regarding that entire process. I think using that as kind of its big data center or big data hub and using the ML approach can kind of characterize that specific process, right? And additive to me is, I guess, much more of a predictive thing. Like if we have a new material, what are the process parameters going to look like? And then will that actually predict a good quality component at the end of the day?
I think from a design point of view, we can look into AI, which is basically generative design. From the AI part, they can definitely create new designs, also start to understand, help to rapid prototype new materials with new designs. But when we are looking at certification, I think AI is a little bit more into the future of being predictive. What we want to rely on right now is the huge data set that Conrad mentioned, and to actually use ML to figure out what the norm is, and to use machine learning to be able to pick up outliers very, very quickly without human interference. So that will create a much faster certification process. It also allows the industry to build confidence as we go along, because confidence needs time. So if you start throwing in too much advanced technology, it's not going to work. But from the design part, yes, we can start talking about AI, not on the certification part.
Yeah, I think just to follow up, I think it's less of a leap to go from current validation methods to an ML method where we're looking at all this data and finding outliers. That's not as drastic of a leap of faith as it is to go to some sort of AI predictive validation. To Michael's point, that first small step is much easier to gain trust in the general public. And then we build from there. You don't want to jump off the cliff right off the bat.
And maybe one of the things that I think we have not touched on, which we want to use in situ certification, is that a lot of test coupons actually end up in the wrong position. So you're not picking up real critical points. You're just trying to do a checkbox. I use the word checking the box. I think sample testing could actually fall into checking the box, because class says 15 coupons, you give me 15 coupons, but are they at the critical locations? We don't know. Are they picking up potential defects? We don't know. But in situ printing will allow you to do that.
Yeah, I mean, that's a great point. And I don't know if this is too far into the weeds, but the witness coupons we print along with every component obviously don't occupy the same volume that your printed component does. So really, this is just a representative sample of what that build job is seeing. But to Michael's point, the actual part is, located, in one XY coordinate. The samples are located another XY coordinate. Yes, we're testing that because it's part of it's being built with the same process parameters. But at the end of the day, are these two actually identical? That's, you could make an argument that they're not. But in situ monitoring does allow you to say, okay, what is going on in my specific part during that process? So I think having that data profile would be key to ML qualifying parts in the future.
It actually enhances safety rather than actually reduce it. Right now, it's just about building confidence on the database that we have.
It's the difference between taking one out of a batch or knowing what every single unit looks like.
Yeah, it's exactly with what Michael's saying. This in situ data per part, you would literally be inspecting every single component as opposed to taking 10 out of 100.
When we talk about robots and autonomous systems, people always want to know what kind of human oversight there is. Michael, what sort of oversight is needed for this data-driven certification? And so I know I mentioned this is the buzzword, but how important is adding that extra layer of trust?
Yeah, I think when everybody talks about data-driven manufacturing, it's always how much human oversight. Is it no human, or there will be human in the loop, and to what extent? So actually, the answer to the question right now is still going to be quite a lot. So what is happening is that in industry like marine and offshore, a single failure can be catastrophic. So humans will provide the additional layer of judgment, accountability beyond what algorithms can actually deliver. So in fact, most regulatory bodies still require documented human sign-off for certification. And why is it so? Because machine learning models aren't perfect, at least not at the moment. So they can misinterpret sensor data or fail under unusual conditions. So human oversights help ensure decisions are made and aligned with safety and compliance standards. It also builds confidence. As companies adopt new technology like additive manufacturing, oversights will help to mitigate risk and data biasness, sensor errors, and even cyber threats. So what does oversight looks like? Maybe just process validation, quality assurance certification, and continuous improvement as well, because models needs to continuously improve and human in the loop will definitely assist.
And Conrad, how do you see that human in the loop role as data-driven validation gets to be more common?
Yeah, absolutely. I think especially in the short term, near midterm future, there's no substitute for a human oversight. We want the community to trust in this process of validation. And I don't think anybody trusts a robot to make those decisions quite yet. But I think that long term, it could be a reality someday. At the end of the day, right now, an algorithm's not going to make a decision on whether something's safe or not.
In a lot of our episodes, we talk about regulations, whether that's safety or environmental, and how they impact technology in the industry. I think additive manufacturing lives in a little different space. So, Michael, what sort of standards or requirements are there for AM, and what's needed to demonstrate that reliability?
So right now, ABS has several key publications. We have requirements for AM technology, which provides formal requirements for standard qualifications. We are also working on a new guidance notes that is basically working on model-based qualification. These aren't just theory. They are actually backed by real projects that ABS has been involved with. For example, ABS just completed a project with NIST to speed up qualification for metal-based AM. Instead of relying solely on extensive physical testing, we introduced model-based approaches like expert systems, in situ monitoring with machine learning, and physics-based simulation. The goal? Faster, cost-effective certification without compromising safety. Building on that, ABS is also leading a maritime-focused project to create qualification framework for data-driven defect detection. Another initiative under NSRP is developing best practices for what we call rapid qualification, delivering guidance, case studies, and method to reduce testing and low certification costs. And right now, IX Recommendation 186 is the first global framework for AM in marine and offshore setting. It applies to metallic additive manufactured parts used in marine and offshore equipment, focused on powder bed fusion, direct energy deposition, and binder jetting technology. One of the big challenge right now is a lot of all these standards, and as what Conrad has mentioned, a lot of certification focus on strength. Moving ahead, ABS is also looking for partnership and collaboration with the industry to work on endurance and fatigue life. That will complete the loop of certification of AM parts.
And Conrad, what about your thoughts on the role of standards in driving that adoption of not just AM, but also the data-driven certification?
Yeah, absolutely. Right now, we kind of have a landscape where every industry has their own body of standards or certifications that they abide by. You know, API 20S for the oil and gas, aerospace has their framework, dental and health have a separate set of standards. It makes me excited to hear all the opportunities that Michael spoke about that's already going on, and opportunities for collaboration in the future on additional updates to the standards as well. I think moving forward, if there was some sort of universal cross-industry specification that everyone could reference, that would help drive adoption even further. I'm much more of a pragmatic person. I don't think that's going to happen anytime soon, but it's exciting to hear the activity going on behind the scenes.
Closing things out, I wanted to give each of you an opportunity to provide some closing thoughts for our listeners. Conrad, you want to take that one first?
Yeah, absolutely. Like I said, I started an additive about 10 years ago. It's come a tremendous way since then. First generation of machines were much more manual. Now there's so much data being collected. The adoption of the design for additive practices is really taken off. We're seeing so many good applications in all industries, really. And I think the next step is really trying to converge on a data-driven validation model. You know, once we get to that point, that really reduces lead time, cost of testing, physical destructive testing that's required currently. And a lot more industries I think will take notice and start to implement more of the additive parts in their assemblies.
And Michael, any closing thoughts?
Yeah, for us, additive manufacturing definitely seems to be the game changer for the future of manufacturing. It brings huge benefits like rapid prototyping, cost-effective designs, and even using less materials. But here's the challenge, which is certification. So building trust and bringing trust into the final product is critical. And right now, that's the biggest hurdle to widespread adoption. The exciting part, data-driven certification powered by machine learning could be the key to unlocking AM as a mainstream process. So at ABS, we are leading the charge, partnering with industry and investing in R&D to prepare the marine and offshore sectors for the future where additive manufacturing is not just an option, it becomes the norm.
All right, great. So machine learning, AI, all those things are certainly buzzy topics, and people in different spheres are exploring how they can impact what they're doing. And that includes additive manufacturing. It really sounds like there's a lot of exciting stuff happening in that space right now. So, Conrad, Michael, thank you both for a really insightful discussion.
Thanks for having me.
Yeah, my pleasure.
And for everybody listening, thank you for joining us for another episode of Setting Course. Be sure to subscribe, leave a review, and share this episode. To learn more about how ABS is supporting additive manufacturing, visit us at www.eagle.org. Thank you for listening.